So welcome again. Today our lesson is electric charges and forces and fields in physics. So the first question we should ask ourselves is, what is an electric charge? So an electric charge is a property of matter that causes it to experience electric forces. So in simple words, if an object has electric charge, it can push or pull other charged objects without touching them. So this pushing or pulling is an electric force, and it happens through something called an electric field. We'll connect this one later. Where do electric charges come from? So all matter is made up of atoms. An atom contains protons, which are positively charged, electrons, which are negatively charged, and neutrons, no charge, which is neutral. But normally, the number of protons is equal to the number of electrons. So the atom is electrically neutral. So electric charges appear when electrons move. So gain electrons, objects becomes what? Negatively charged. When it gains electrons, when a charge gains electrons, it becomes negatively charged. And when it loses electrons, objects becomes what? Positively charged. And one thing you should know is protons do not move in solids. Electrons are the ones responsible for what? For charging. So having talked of that, let's go to the kinds of electric charges. So there are only two kinds of electric charges. The first one is positive charge, which is caused by loss of electrons. The second one is before we go to the second one, object has more protons than electrons. The second one is negative charge, caused by gain of electrons, and this one, the object has more electrons than what? Than protons, because of the gain of electrons. So a positively charged has more protons than electrons, while a negative charge has more electrons than protons. There is no third type of what? Of charge. So those are the two types of electric charges. Now, what are the properties of these electrical charges? Let's look at the properties of electrical charges. So the properties of electric charges, the first one is like charges repel. So the first two properties are like charges repel and unlike charges attract. So positive repels positive, negative repels negative. For example, two negatively charged balloons push each other apart, and a charged plastic room attracts small pieces of what? Of paper. So this is the first property of electrical charges. Like charges repel and unlike charges attract. The second one is charge is conserved. So charge cannot be created or destroyed, it can only be transferred. So when a glass rod is rubbed with silk, glass loses electrons and it becomes what? Positive, and silk gains electrons and becomes negative. So total charge before is equal to total charge after. So this one is just like law of conservation of energy. So for this one, charge is conserved, it cannot be created nor destroyed, it can only be transferred from one place to another, from one object to another. So the last one is charge is quantized. So electric charges exist in discrete amount, not continuous. So the last one is charge is scalar, which means charge has magnitude only, no direction, unlike what? Unlike forces. So it is a scalar quantity. So let's talk about attraction and repulsion of charges. Why do charges attract or repel? So they do this because charges create electric fields around them. So a positive charge creates a field pointing away. So a negative charge creates a field pointing towards itself. So when another charge enters this field, it experiences a force. This explains action at a distance. No contact is what is released. So charges create electric fields around them. So for a positive charge, it creates a field pointing away. So for a positive charge, it creates a field which is like this, pointing away. So for a negative charge, a field which is pointing like this towards itself. So that's why a positive charge and a negative charge will attract, because this one it's pointing away and this one is going to like receive. So at the end they attract. But what if it's also a positive and a positive? You are seeing this, they are all pointing away. A positive charge, at the end they repel. So that's what happens. So a negative charge will create a field pointing towards itself, while a positive will create a field pointing away. So at the end, when another charge enters this field, it experiences what? A force. This explains action at a distance. No contact is what is released or required. Let's look at another interesting subtopic, which is conductors and insulators. So this explains why some materials can be charged easily and others cannot. So let's start with a conductor. So a conductor is a material that allows free movement of what? Of electrons. Example of a conductor, it can be metals, which is copper, aluminum, iron, and many more, graphite, human body. So one thing that you should know is, in conductors, electrons move freely, charges spreads quickly over the surface. That's why light in conductors works. So in conductors, the reason why it can conduct maybe electricity or what is it, because here charges spreads quickly over the surface and the electrons move freely. Let's talk about insulators. So an insulator does not allow free movement of what? Of electrons. So the examples, they can be plastic, rubber, glass. That's why they are bad conductors. It can either of heat or electricity. But in insulators, electrons are tightly bound and charge stays where it is placed. So what's the difference between conductors and insulators? So we are going to find that when we are talking about electron movement, in conductors, electrons are free to move, and in insulators they are restricted. What about charge flow? Charge flow is easy in conductors, but it's difficult in what? In insulators. The examples for conductors, metals; for insulators, plastics and rubber. Now let's talk about charging of objects. So charging means making an object electrically charged. So when you're talking about charging, this is just making any object or making an object what? Electrically charged. So there are two main methods you must understand clearly for charging. There are two methods. The first one is charging by conduction. The second one is charging by induction. This one you should really pay much attention, because it usually comes in the exam when you're talking about charging by induction and charging by conduction. So let's start with charging by conduction. So for charging by conduction, so this is a charging which involves what? Contact. For a charge to happen, they supposed to happen. A contact supposed to what? To happen. So what happens? A charged object touches a neutral object, then electrons move due to direct contact. So example, a negative charged rod touches a neutral metal sphere. So let me try to illustrate this one. So a negative charged rod touches a neutral metal sphere. So let's put something like this. This is a neutral metal sphere, which means it has positive and negative, positive and negative. Then you bring a negative charged rod. So this rod is negatively charged, and there is contact there. Electrons flow from the rod to the sphere. So all these electrons are going to move from the rod to the what? To the sphere. Both objects end up negatively charged. So what happens is, so this is illustration is just short, but it won't be complete. But what happens when this negative charge is going to come here? So you are going to find that it's going to attract the positive charges. So leaving the sphere with a what? Negative charge. At the end of the day, the sphere is going to be what? Negatively charged. So the important rule which you should know is the neutral object gets the same type of charge as the charged what? The charged object. So whenever you are bringing a charged object to a neutral object, the neutral object is going to have the charge which the charged object had. Also, note that charging by conduction requires physical contact and happens mainly with conductors. Final charges are the same sign. So this is all about charging by conduction. It's all about what? Contact. When we are talking about charging by induction, this is more conceptual but very powerful. So what is induction? So induction is charging an object without touching it. So let's go step by step. So for example, bring a charged object near a neutral conductor. So do not touch, just bring it to a what? To a neutral conductor. Then charges inside the conductor rearrange. Electrons move due to the attraction or repulsion. Then bring the earth. So earth the conductor. So some electrons flow to or from the ground. And then remove the earth connection and remove the charged rod. So the conductor is now charged even though there was no contact. So what happens in this one? Is, for example, there is a neutral sphere here. Bring a charged object. So for example, a negatively charged again. A negatively charged. Negative. This is neutral, which means it has positive and negative charges. So charges inside the conductor rearrange. So what's going to happen there is, since it's negative, there's no contact. Since it's negative charge, positive charges will come this side, and negative charges will come this side. So what's there is, after this, electrons have moved to the right because of repulsion. Then earth the conductor. Then you bring the earth wire here. So what's going to happen is, all these electrons are going to flow to the what? To the ground. Then remove the earth connection and remove the charged rod. So at the end, the sphere is going to be what? Positively charged. So you have charged that object, but there was no contact. So the essence is, you just bring the charged object near, then there's going to be rearranging of what? Of charges. The positive charges are going to move near the charged rod, and the negative charges, when you put the earth wire, they are going to flow to the ground. At the end, the object is going to be charged. So this type of charging is what we call charging by induction. The important point that you should know is, important result is, the conductor gets a charge opposite to the inducing object. Now you have seen the key here. The rod was negatively charged, but after the sphere has been charged, it's positively. That's why we are saying the conductor gets a charge opposite to the inducing object, and no electrons move from the inducing rod itself. So no electrons are moving there because there was no contact. So why does induction matters? Induction matters because it's used in electrostatic shielding, used in lightning protection, used in Van de Graaff generators. So this is all about this lesson on electric fields. Next time we'll look at another subtopic also in electric fields, probably electric fields, if I'm not wrong. So this is the end of the video. Thank you for watching. If this video helped you in any way to understand electric charges, give it a like and subscribe for more videos.